In this section, we're going to be taking a look at analyzing the graph of a polynomial function. And for this problem, we're going to go ahead and work through each of these steps. You'll see a summary provided on this slide. So let's go ahead and take a look at the problem itself, and then we'll start with step 1. So for this problem, we're going to be working with the function f of x equals 2x plus 1 times the quantity x minus 3 squared. And the first step here is we're going to be taking a look at the end behavior of the graph of the function. And in order to do that, we want to go ahead and multiply this function out. So let's do a little bit of rewriting. This is the same thing as 2x plus 1 times x minus 3. And that term was squared, so keep in mind that means we're multiplying it by itself a second time. And we want to go ahead and take two of these factors so that we can multiply them together. Okay. If we distribute these two terms out, that's going to give us x squared. We'll have a minus 3x and another minus 3x for a total of 6x. And negative 3 times negative 3 will give us a positive 9. Now we can go ahead and multiply that by the 2x plus 1. Right, your choice how you want to go ahead and multiply this. I'm going to use the box method. In the box method, you can go ahead and put one of your polynomials across the top. I'll use the trinomial for this part. And then down the side, we'll go ahead and put the 2x plus 1. Right, and the idea here is you're going to be distributing the 2x plus 1 times that trinomial. Using this box method just makes it nice because you can kind of organize your work to make sure that you don't miss any terms. So we're going to be taking the 2x and multiplying it by each of those terms that you see on top. So 2x times x squared will give us 2x cubed. 2x times a negative 6x will give us a negative 12x squared. And 2x times positive 9 will give us a positive 18x. Right, we'll do the same thing for the second row. We'll take the positive 1 and multiply it by everything we see on top. So x squared times positive 1 will give us a positive x squared. 1 times the negative 6x will give us a negative 6x. And 1 times positive 9 is a positive 9. And now we can go ahead and combine our like terms. Right, most of them are going to appear here on the diagonal. Right, so for our function, once we have everything multiplied out, we've got 2x cubed. We have a negative 12x squared and a positive x squared. If we combine those terms, that's going to give us a negative 11x squared. For our x terms, we got a positive 18x and a negative 6x. We add those together, we're going to get a positive 12x, and then we'll have our plus 9. Right, so there's our function multiplied out. Right, and so we can take some information off this. Right, our leading term is that 2x cubed. So our graph is going to behave like a 2x cubed function. If we just give ourselves a little mini sketch of the 2x cubed function, it'll look something like this. So it's going to start low and end high. So let's go ahead and take a look at our next step. For step 2, we want to find the x and y intercepts of the function. So let's go ahead and do the x-intercepts first. Keep in mind when you're finding x-intercepts, right, your y value is going to be equal to 0 in that case. So that's the same thing as setting our entire function equal to 0. So we've got 0 equals 2x plus 1 times that quantity x minus 3 squared. And if we want to solve this, we can go ahead and take each of our factors here and set them equal to 0. So 2x plus 1 will be equal to 0, and x minus 3 is also equal to 0. And then we can go ahead and solve each of those equations. And we're going to end up with two values here. We'll get an x value of 3, and we'll have an x value of negative 1/2. Right, so two different intercepts here. The y value is 0 for each of those. So we have the point 3, 0, and the point negative 1/2, 0. So let's go ahead and find our y-intercept next. Keep in mind when you do your y-intercept, your x value is going to be equal to 0. So we'll take our function, and in place of each of those x's, we're going to go ahead and plug in a 0. So we've got 2 times 0 plus 1 times 0 minus 3, that quantity squared. Okay, so this will give us positive 1 times a negative 3 squared. Negative 3 squared is a positive 9. Okay, so our y value is going to be equal to 9. So as a point, right, our y-intercept will be the point 0, 9. For step 3, we'll be taking a look at the real zeros and their multiplicity, and we'll use that information to determine whether the graph crosses or touches each of those x-intercepts. So let's go ahead and take a look at our zeros. We had x values here of negative 1/2 and 3. And we'll take a look at the multiplicity of each of those. Keep in mind the multiplicity is the exponent that's on the factor itself. So on the factor where we have that 0 of negative 1/2, right, our exponent's not written, but it's really a 1 up there. So this multiplicity would be a 1, right, which is an odd number. So anytime we have an odd multiplicity, our graph is going to cross at that 0. The 0 of 3, our multiplicity up there on that factor was a 2. Right, that's an even number. So anytime we have an even multiplicity, our graph is going to touch at that x-intercept. Let's go ahead on to our next step. At this point, we can go ahead and use some type of graphing utility to graph the function. You can use your graphing calculator, or you can use Desmos, whatever is going to be easier for you. And we have a sketch of our function up here, and then we can go ahead and approximate the turning points of the graph. Keep in mind that those turning points are where your graph is changing direction from increasing to decreasing, or decreasing to increasing. Right, so we have a couple points on our graph. I'll label these turning points. Right, we have one of them here at the point 3, 0. Right, that's where our graph changes direction. This would be a minimum on our graph, right, because our graph is going from a period where it's decreasing to a period where it's increasing, right? And this point 3, 0 is where it would change those directions. And then we also have another turning point up here at the max value, right, where your graph changes from an increasing function to decreasing afterwards, right? And then we can kind of use all of our information to sketch this by hand, right? Remember, this graph resembled the 2x cubed function, and we had intercepts of negative 1/2 and 3, right? And then we had a y-intercept of positive 9. And going back to our last step, right, we were talking about the multiplicities and how that impacted our graph. If we have an odd multiplicity, our graph is going to cross right at that x-intercept, or that 0 of -1/2. And since we have an even multiplicity on the 3, our graph is going to touch at that point. So taking a look at our next step, we want to find the range of our function. Remember, the range is how far up and down your graph goes. We want to list the y values from our graph. And our graph goes downward forever, indicated by this arrow on the end. It's also going to be going upward forever. So this graph will have a range from -infinity to +infinity. And for the last part, we'll determine where the graph is increasing or decreasing. Keep in mind, if your graph is increasing, right, it's going uphill as you look at it from left to right. If it is decreasing, it's going to be going downhill as you look at it left to right. So let's go ahead and highlight a portion of our graph. And we'll go ahead and highlight this segment where it's increasing. Right, it's going to increase until it gets to its max value. And we actually have two sections here where our graph is increasing. So let's go ahead and write our intervals for each of those. Remember, when you write these intervals, you're going to be giving the x values over which it occurs. Right, start with your lowest x value first. So we have from -infinity all the way until it hits this max value, right? We want the x value here, which is that 0.67. And then we have our second interval here. It's going to start at +3. And it's going to continue increasing all the way to an x value of +infinity. So let's go ahead and take a look at the decreasing portion of our graph. Right, that's where our graph is going to be going downhill as we look at it from left to right. Again, we're going to be giving x values. So our smallest x value here is going to be that 0.67. And it's going to continue decreasing until it gets to this x value of 3. So I'll put that summary back up on the screen for you. So keep in mind, when you're analyzing the graphs of these polynomial functions, go ahead and work through each of the steps so that you can get your function graphed, and then you can answer each of the components.